Math Tutorial Application Problems by Luisi and Pedro. When dealing with application problems, quadratics can be very useful. A few formulas that should be used when solving application problems are the quadratic formula, which is negative b plus minus the square root of b squared minus 4ac over 2a. This formula allows you to discover when will your graph hit a certain line. In application problems, it can be used to determine how long will it take for the object in question to reach a certain height. The quadratic formula will always give you two answers because there is a plus and a minus symbol. This makes sense because, as your graph is in a parabolic curve, it will always hit the line twice, with the exception of the vertex. This second formula allows you to find the center of your graph, its line of symmetry, and the x-coordinate of your vertex, as the vertex is always on the center of the graph. Lastly, this formula allows you to find the y-coordinate of a point when given the x-coordinate. This formula is very helpful when determining the vertex of a graph. When using those equations, one must know what the value for each variable means. A represents the force of gravity, or negative 4.9. B represents the speed at which the object is flying. When an angle is given, then B becomes the sine of the angle multiplied by the speed. C represents the height from which the object is thrown.
Here are a few sample problems. Mighty Girl is thrown off a cliff at a height of 70 meters at a speed of 15 meters per second and at an angle of 45 degrees, making a parabolic curve as she first rises and then falls. Next to the cliff, there's a sea at height 0. What is the highest point Mighty Girl will reach? How long will it take her to hit the water? First, let's determine the value of each variable in the equations we will be using. A will be negative 4.9, representing the force of gravity, and C will be 70. To discover B, we must first discover the sine of 45, 0.7. Then, we multiply this value by her speed, 15. Our B value is, therefore, 10.5. To discover the highest point Mighty Girl will reach, the vertex of the graph, we need to first find its x-coordinate, the center of the graph, using the negative b over 2a equation. Negative b is negative 10.5, and 2a is negative 9.8. After we solve this, we will arrive at 1.07. This is the x-coordinate of our vertex, and the time, in seconds, that Mighty Girl will take to reach the highest point. Now, we need to discover how high she is going. As we know the x-coordinate of the vertex, we can now use y equals ax squared plus bx plus c formula. We simply plug in the values, and then 1.07, the x-coordinate of the vertex, for x. Ax squared is equal to 5.61. Bx is equal to 11.23. And c is 17. After we add those values, we will arrive at 75.62. This is the highest Mighty Girl will go. To discover how long it will take Mighty Girl to hit the water at line 0, we must use the quadratic formula. X equals negative b plus minus the square root of b squared minus 4ac over 2a. First, we plug in the values. A is equal to negative 4.9, b is equal to 10.5, and c is equal to 70. Now, we solve this equation. First, we multiply negative 4.9 with 70. Then, we'll multiply it by negative 4. This gives us 1,372. We also squared 10.5, which gives us 110.25, and multiply negative 4.9 by 2, which gives us negative 9.8. After adding 110.25 and 1,372, we square root this value, which gives us 38.5. We choose to subtract this value from negative 10.5. Then, we divide it by negative 9.8. Our answer will be 5. Therefore, The amount of time it'll take Mighty Girl to hit the water is 5 seconds.
Now let's move on to another sample problem. John passes a ball to Jack. This ball is thrown at a 65-degree angle at a speed of 10 meters per second, making a parabolic curve as it first rises and then falls. The ball is at a height of 2 meters when thrown. Jack is going to intercept this ball at height 2 also. How long will it take for Jack to catch the ball? Now let's take a look at our variable values. Our A value is going to be negative 4.9, the force of gravity. Our B value will be the sine of 65, 0.9 multiplied by 10, which will equal 9. Our C value will be the height John threw the ball from, or 2. This time, the ball is going to be received at height 2. Because that is the case, we need to change some variables so that we know when will the ball reach Jack's hand precisely. So, our equation will look like this. 2 equals negative 4.9 x squared plus 9x plus 2. We subtract 2 from both sides, and after plugging in the values, we will arrive at this equation. 0 equals negative 4.9 x squared plus 9x plus 2 minus 2. Simplifying this, we will have 0 equals 4.9 x squared plus 9x. Our C value will be 0. Then we plug it in the quadratic formula. First, we need to plug in all values in the quadratic formula. Then we multiply A by C, or negative 4.9 by 0, which will equal 0. Then we multiply 4 by 0, which will also equal 0. We can also already simplify 2 times A, or 2 times negative 4.9, to negative 9.8. Then we need to square B, which is 9, which squared will equal 81. Then we see the square root of 81, which is 9. We then subtract 9 from negative 9, which equals negative 18, and divide negative 18 by negative 9.8. Our final result will be 1.83. This is how long the ball will take to reach Jack. Here we can see a picture with all the coordinates plugged in for your better understanding. So let's sum up everything we said in this video. In this video, we learned how to solve application problems using quadratics. We learned how to discover the vertex of a graph, or the highest point the object thrown will reach, how long will it take to reach this point, and how to discover the time taken by the object to hit certain heights. To discover the center of the graph, or the time the object will take to hit the vertex, we use the formula negative b over 2a. Then, to discover the height of the vertex, we plugged in this value in the formula y equals ax squared plus bx plus c. To discover how long it'll take to hit the ground, we use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. If we are trying to discover how long will the object take to hit a height that is not 0, we must subtract the value of its height from our c value, and then solve the quadratic equation. Thank you all for watching.